Yeah, so coming to this one, see what happens is whenever you have a magnetic field, uniform magnetic field, and inside that you have a rod which is rotating. So if it is rotating about an axis like this at an angular speed omega, then you know that any section in it has a speed of r omega, where this distance is r. If you take a differential element of thickness dr, you should know all this from before. So the EMF induced across that small section is BLV ke jagah BV dr. So B omega r dr, it becomes that. So now the EMF across the whole thing. So the polarity of the EMF here, you can see V cross B is pointing towards that side. So it will be like this. It's like a small EMF, which is like this. So the total EMF, this point P and this point Q, will become like this. VQ minus VP will become B omega L square by 2, where L is the whole length of the rod.
Yes, sir. Yes, sir.
So what is happening in this case is you are having this thing, like a ring like this. So the ring doesn't have any resistance, nor does the rod which is acting like the diameter. Okay. There is like a rod like this, just placed on top of it, and it's slipping freely over here. This rod just rotating about this fixed axis. I think they're shown clockwise over it. Like this. Okay. If you take this center point as C and these 2 points as A and B, whatever, you can see that because the magnetic field is going into the plane. So again, and because I'm taking omega like this clockwise, so these points are having velocity downwards.
Yes, so it would be B omega r square.
And this section acts like a battery like this. And your E1 is equal to E2 is equal to B omega r square by 2, because you've taken the radius of this thing.
Yes, sir.
So now what is the problem? Now it's just you have to apply KVL concept. So you have applied one resistance like this and another resistance like this. So suppose this R1, this R2. Now you can see that if this point is, let's say, D and this point is E, so the potential of all these 4 points is same. A is equal to B is equal to E equal to D, and the potential, let's say that is some V1, and the potential of the center is some V2. Okay, so V1 minus V2 is, you can see, equal to this EMF for this EMF, which is B omega r square by 2. So each of the resistances having that much EMF across it, or that much voltage across it. So
okay, sir.
Sure,
so the answer is C, no?
So according to that, the current should just be this EMF divided by that voltage. So that should be the answer. Okay.
But in the last page, the answer is given option number A. That can't be, no?
Okay, let me just check. Answer should be B omega r square by 2 divided by resistance R1. So that's correct, no? Current through R1 तो उतना ही होगा ना? That EMF divided
okay,
by
current through R1. Yes. Okay. A. Okay.
And current through R2 will be option B, and the net current is the sum of the two. So that also you can get, that will be C, I think, when you check. So the net current in both the resistors combined will be C. In two alone will be that much. In one alone will be like that. Okay. So anyway, that's that question. Now let's move on to. This is another doubt you have, no, Kritika, this question. Difference between current and voltage.
27. That second question.
Let me just. So which one? 27th one. Okay. Yeah. So both of you just take a look at this question. I will discuss. Phase difference between current and voltage is pi by 4 radians. The frequency is 50 hertz and the phase difference between is equivalent to time difference of how much? अच्छा. Phase difference और time difference का क्या relation होता है? Omega delta t is equal to phase difference. So if your phase difference is pi by 4, in terms of time, it is how much difference? It is omega delta t, where omega is 2 pi f. Got it now? So omega is 100 pi. So just divide pi by 4, divide by 100 pi. So you get the time in seconds, and then convert that to milliseconds.
Sir, can you repeat please?
Is it clear, Kritika?
So can you repeat?
It's the relationship between phase difference delta phi and time difference delta t from waves only. So if phase difference is delta phi and your time difference is delta t, then the relationship between the two is phase difference is equal to omega into time difference delta t. Okay, so phase difference delta phi should be equal to omega into delta t, and omega is how much? 2 pi into frequency. Frequency going to has 50 hertz. Right? So that is how I'm calling. So just divide that phase difference pi by 4 divided by omega, which is 100 pi.
Okay, sir. Okay.
Time in seconds. So
Okay.
is that waves ka concept, the relationship between phase difference and time difference.
Okay, sir.
Yeah. Now I'll just come to one of Arman's questions for a bit of time. Yes, I'm just sharing this question now. Okay. Yeah, so is it coming on your whiteboard? Are you people getting this other question, the one with the pulley and the two strings, is appearing on your whiteboard?
Yes.
Okay. So let us see what's happening in this question. So basically, what is the concept we'll use over here? That when you cut some thread or something, the spring's tension remains the same. Okay. Now, anything given about the masses of the blocks, Arman?
Sir, which question?
The question which is
just
on
a
the.
minute. I think I forgot to send the entire
Forgot to?
question. Just a minute, sir.
Yeah, you are having the question on your screen, na? Are you getting it or not?
Yes, the
Sir, I'm
masses
not
are.
able to read it.
I've shared it.
blur.
I've shared it on the screen for
Masses
you.
are
You should
A.
be getting the.
Okay, sir.
Sir, A and B
Yeah,
are
just tell
of
the mass.
3m and C. A and B are of 3m and rest all are of 2m.
Okay. So A and B are 3m each, and the other three are 2m each. So on both sides, the total mass is the same, 6m and 6m, right? So the system
Yes.
is in equilibrium.
Yes, sir.
Okay. Now tell me how much will
Yes.
be the tension in spring 1? The tension in spring 1 will be 6 mg,
Yes.
right? In the diagram, the spring on the left, Kritika, you are able to see the spring on the left.
Yes, sir.
So उसमें कितना tension होगा? Spring 1 में suppose you write the tension as K1 x1. So that K1 x1 is how much? 6 mg initially.
Yes, sir.
And similarly, spring 2 has how much tension? 2 mg.
सर माचेस क्या थे? A and B का 3m है and C D E का
2 2 mg.
2m each.
okay.
2 mg. Okay, so that they are counterbalanced. So the second spring has how much tension?
2
It has
mg.
2 mg. Okay. So now see what is going to happen. If you at a D option में doubt in Arman. So after this spring C, is the thread between C and the pulley. So that means between C and the pulley is cut. Tension in the string CD is how much? Okay. So when you cut the thread just above C, so D option वही कह रहा है ना, that you want to cut the thread just above D. Right?
Yes, sir.
Just above C, not just above D, just above C. So what happens in that case to the tension in spring 1? That's the main thing over here, to understand. What happens to the tension in that thread? In that spring 1, when you cut the thread just above C.
So remains constant, ना? So क्योंकि spring में tension suddenly change नहीं होता है.
At one end, wait. At one end of the spring, you have cut the thread. There is no inertia attached. You understanding?
Okay. Yes.
That spring's tension will become 0.
Sir, so it will decrease.
No, it will become 0. Spring को एक तरफ से release कर दिया ना, cut कर दिया.
अच्छा हाँ sir.
Okay. So spring 1's tension suddenly becomes 0. So what happens to the side A and B? The side A and B becomes free falling with acceleration due to gravity G.
Yes.
Understood ना Arman? Now अभी देखो C पे क्या हो रहा है, C और D पे क्या हो रहा है, let's understand. So spring 2 पे tension कितना रहेगा? It will still remain 2 mg.
Yes.
Okay. So D is getting pulled down with a force of 2 mg plus it has its own weight.
Yes.
So it pulls C down along with it.
Yes.
So now you make CD a combined block. So that combined block is having weight 4 mg plus the spring is pulling it out down with 2 mg. So उसपे net force कितना लग रहा है? 6 mg. So its acceleration will become how much? 6 mg divided by mass, which is 4m. So that is 3 by 2g. So the combined block C and D, it starts coming down with a acceleration of how much? 1.5 g. The combined block E and B starts coming down with g. Whereas what about the acceleration of the block E just at that moment? It will remain 0.
सर वो कट कहाँ से किया, मतलब वो स्ट्रिंग और डी के बीच में या फिर स्ट्रिंग और जो डी एंड सी.
Ritika, listen to me. Read the option D. It is clearly saying where it is cut. Read the option D. It is clearly telling you where it is cut. It is saying it is cut between the pulley and the block C. You're seeing the diagram, no, beta?
हाँ सर बट उसमें
हाँ, so it
डी
is cut
के ऊपर या फिर डी के नीचे.
बेटा क्वेश्चन पढ़ो. ऑप्शन डी for Delhi we are talking about.
Yes,
After
sir.
between C in the block in the diagram, see where the block C is. So you're cutting the thread between the pulley and the block C. Understood now? Where
Okay, sir. Sorry.
cut कर रहे हो thread को आप. You're cutting the thread right at the top.
Okay, sir. Sorry. Sir, I accidentally done it.
So what happens when you cut the thread right at the top? That is what happens, which I just showed you. Okay. So the moment we cut this thread at the top, when you cut this thread right at the top, this is what will happen. You're cutting it over here, right? So this tension becomes 0. Spring 1's tension becomes 0. So do I need to work out this question or is it clear?
Sir, it's okay. Clear.
Arman, this question is clear?
Yes, sir.
Spring 1 का tension 0 हो गया तो E भी free fall में नीचे आ जाएगा, है ना? And the tension between A and B will also become 0 because both of them are in free fall. They're coming down with G.
Yes.
But if you look at the block D, it is getting pulled down by a tension of 2 mg because of spring 2. So that system C and D, it starts coming down but with an acceleration of more than G, and that will be 1.5 G. Whereas the block E, just for that moment, its acceleration remains 0, just for that moment. But then the spring relaxes a little and its acceleration changes.
So the tension in the string between C and D will become 0 or something else?
नहीं, because see, D को नीचे pull कर रहा है ना, spring.
अच्छा.
Spring pulling D down. That's why the system is having an acceleration of more than G, no? So now think of C's free fall diagram also. Its acceleration is more than G, no? So that means that thread is pulling it down. The thread which is attached with it with D.
Okay.
Got it now?
So the answer would be the tension in it
What is the
decreases.
question actually asking? Tension in the thread CD. Okay. So tension in the thread CD initially will be very large now, because it will be maximum because the acceleration is G by 3G by 2 downwards. But then what happens as the spring 2 is relaxing, उसका downward acceleration कम होने लगता है ना, eventually it becomes G.
Okay, so decrease.
By the time the spring 2 comes to natural length, what happens to tension in the thread CD? It will become 0.
Okay.
Got my point?
Yes, sir.
So what is happening? The moment you cut the thread between C and the pulley, D and C start coming down with 1.5 G, whereas E is at that moment at rest. So that spring is relaxing. That spring 2 is relaxing. And as it relaxes, now E starts to increase in acceleration from 0 to something more gradually. Whereas that system C and D, uska acceleration kam hone lagta hai from 1.5 G. Now eventually by the time the spring comes to natural length, what happens is that all three of them have the common acceleration of G. So at that time, when all three of them have common acceleration of G, the thread between C and D will have zero tension.
Zero.
Okay, sir, got it.
And from that time onwards, got it? Understood?
Yes,
Yes,
sir.
sir.
So now I'm moving on to the next problem, which Arman has sent.
Sir, it is in
Which
this.
is-
There is another doubt in that same picture above.
In which one? In that one? Another option
Yes.
is,
No, the
yeah, which
next
option will you tell me?
question, 46, 5.46.
Next question. Okay, 5.4. Okay, let me see if I can maximize this. Yeah. Okay, so you guys just go through this and I'll bring this on the whiteboard. Okay. So all the contact points are smooth. Springs and strings are light. Okay. E is held by someone and B and C are at rest and in equilibrium also. So you have to find the acceleration of block C just after the block A is released. And the masses are M, M, and C has a mass of 2M. Okay. So again, this problem you have to start that way. Imagine you are holding the block A. So first of all, find out how force you would be applying on the block A. And here you realize you must be pulling the block A downwards because block A has a tendency to accelerate upwards. Because उस तरफ C का weight ज़्यादा है ना.
हाँ.
So you are pulling A downward with some force such that all three are in equilibrium. Now find the state of the spring. How much tension the spring has. Now the moment you release the thread, you release the block A, what happens at that moment? The spring's tension will not change. It will remain. Suppose it was K x naught. It will remain K x naught. But the other thread, the one joining A and B, uska tension suddenly change ho jayega. Getting my point? So this is the key to solving the problem. That when you release the block A, immediately the tension of the thread, the one which is joining A and B, that can change. But the tension on the other side, the one joining B and C, that will not change because that has got a spring, and you're not cutting the spring, so the tension will not change suddenly.
Okay.
So its tension will remain how much? Kx, and rest you apply free body diagram separately to A, B, and C, and you'll get the answer. So just try this out. I'll put it up on the whiteboard. But if you understood the method, I'm saying just try it out.
सर अगर ए को होल्ड करके रखा है तो कितना टेंशन रहेगा सर बी में?
Your answer will be 0 for C.
Yeah, so Man and Kritika, have you got that question?
Sir, if
Yes, sir.
in the right side, if the tension does not change, then the acceleration will be zero, na?
Huh. So momentarily, na. So let's see what the question is again asking exactly.
सर एक्सेलरेशन जी होगा क्या?
So what is happening in the question on the right side where C is there? So C ke body diagram. Now what is the question asking? Immediately, just after the block A is released, what is happening? So just after the block A is released, what is happening is that if you look at C's free body diagram. So just a minute, I will make the FBDs. Just a minute. Yeah, so sharing the, so must be getting the whiteboard now. Yeah. So see what is happening on that side to block C. In C's free body diagram, just at the moment when you cut the thread, this is kx not only. So that is equal to 2 mg. And its weight is 2 mg because its mass is 2 m. So its acceleration is remaining 0 just at that moment. Whereas if you look at block B, what is happening is from this side the tension is kx naught, which is 2 mg. Okay. But from this side the tension has changed. It's not the initial value. So it's some t. And again now on this block A, this tension is the same as that tension, but its value has changed from the initial value. It's become mg like this. Okay. So now this and this will have common magnitude of acceleration. A will have some acceleration A upwards. This will have some acceleration A towards the right, whereas this one's acceleration is 0. So acceleration of A will have the same magnitude of acceleration as B, which is going to be kx naught minus mg divided by m plus m. Is this equation correct? I have written a direct equation, but that you will get by solving the FBD of this one horizontally and the FBD of this one vertically. Clear, Arman and Kritika?
Yes, sir.
Okay. So ये acceleration कितना हो जाएगा? 2 mg minus mg, that's mg divided by 2m. So g by 2 हो जाएगा. Now when you substitute kx not equal to this. So at the moment when you just cut the thread, this is what should happen. The blocks A and B should have an acceleration of g by 2. A is g by 2 upwards, B is g by 2 towards the right, whereas C's acceleration at that moment should be what? 0. And that is what they've asked in the question. Only C's acceleration. So वो तो ऐसे ही आ गया. Understood, both of you?
Yes.
Okay. So this question is clear, right?
सर अगर अगर बी लेफ्ट साइड पे g/2 एक्सेलरेशन से मूव होगा तो वो बाकी पार्ट भी तो नीचे जाएगा ना?
नहीं राइट की तरफ हो रहा है बेटा. See, B's acceleration is it is towards the right because this
Yes.
kx not exceeding na.
Yes, sir.
You see that this tension will come out when you solve this tension will come out to be 3 by 2 mg because kx naught is 2 mg, and that's why that common magnitude of acceleration will come out to be g by 2. Okay. Just like this. But this is just momentarily. Okay. Then what happens? See, the distance between B and C, it starts reducing now because C at that moment is at rest. This fellow started accelerating with g by 2. So the spring is relaxing. So as the spring relaxes, this kx naught changes to kx, which is gradually becoming lesser and lesser compared to 2 mg. So now C will also start accelerating. B's acceleration will become less. So eventually all that will change. This is just at that particular moment.
Okay.
All right. So that does that question. Now I'll come back to one more question. So Arman will do this question about the car on the inclined plane next.
Yes, sir.
Okay. So just try to bring this to the board. Okay. So just tell me, are you able to see the question properly?
Yes, sir.
Okay. So just go through it, we'll discuss. So car is moving on a plane inclined surface at 30 degrees to the horizontal with an acceleration of 9.8, parallel to the plane upwards. A bob is suspended by a thread from the roof. The angle in degrees with which the thread makes with the vertical is how much? So इसमें क्या करना है? We have to make the FBD of the bob, and it's at rest with respect to what? With respect to the car, right? So we have to make the FBD in which frame? In the car's frame, which is a non-inertial frame. So that is how we'll solve this problem. Okay. Let me explain the question. The question is basically something like this. You have that inclined plane, which is at 30 degrees to the horizontal. अभी इस inclined plane के अंदर you have that vehicle. Let's say going up at G, because 9.8 only we have taken as G. So this is going up with an acceleration E, and that acceleration magnitude happens to be 9.8 meters per second. It's acceleration only. No? Just a minute. Yeah, it's going with a constant acceleration of 9.8. Now bob is suspended from the roof. So the bob will experience a pseudo force in sort of the downward direction. So the bob should be in some kind of situation like this. It should be at rest like this, where it makes some kind of an angle with the vertically pucha hai. So let's say I label that angle as something theta or phi or whatever. Yeah, so this angle we have to find out. Right, so this is the question. The bob is in equilibrium with respect to the car. And I think G also we have to take as 9.2. Okay, so the acceleration due to gravity G, it has the same value. So Arman, what is the problem in this? You are not getting the answer. Because all you have to do is very simple. You have to make the FBD of the bob with respect to the car. And the car is a non-inertial frame. Okay? So if you consider the FBD in the non-inertial frame, so your car's frame, that frame is going like this. Its own acceleration is E at an angle of 30 degrees with respect to the vertical. Okay. So make the FBD and see the forces which are acting on it. Pseudo force will be in what direction? Opposite to the acceleration.
Yes.
And apart from pseudo force, what all will be there? There will be mg
Yes.
and there will be tension.
Yes.
So make those forces and just show the equilibrium condition for it. Okay. So try this out, people. Okay. So on your bob, there is pseudo force like this. There is mg like this, vertically downwards. This is the direction of your incline. This is the direction perpendicular to you. Okay. So this angle is 30 degrees. Okay. And your tension now will be in some general sort of direction like this. Tension का जो vector होगा वो ऐसा होगा. somewhere like this. And that is in fact what will represent the direction of the thread, because inside this thing, the card, if the thread is like this, then that is the direction in which tension is acting. So I actually want to find this line with respect to the vertical. The line of action of tension I want to find with respect to the vertical. So this ultimately now becomes a vector problem, and it's very easy because these two vectors are equal in magnitude. You can see that tension as a
I'm getting
vector.
60 degrees.
Okay, so let me just verify that. It should balance the sum of mg and ma as a vector. Right, this is the vector equation for the equilibrium. Okay. This equation is correct, no? It's clear to both of you. Tension is minus of mg plus ma as a vector because the net force on this is 0.
Yes.
Right? So if we modify this FBD a little more as per the laws of vector algebra to make life easier. So ye bob pe, there is one tension vector which is one ma vector which is acting like this. Is at 30 degrees to the horizontal. So let's say it's like this. This is ma, and there is one mg vector which is acting like this. It is vertically downwards. It's like this. So now these two vectors, interestingly, because now this angle is 30 for this. So this angle is 60. Correct. So their vector sum, because these two are equal, their vector sum will act along this bisector. So when I calculate these two vector sum, I can just go with parallelogram law kind of thing. So the parallelogram will actually become a rhombus. So in this diagram, now my vector sum of ma and mg will look like this. Look like it's bisecting this angle. It's acting along this direction. So this thing is actually my ma plus mg. Okay. और इसका magnitude कितना हो जाएगा? Because this is mg in magnitude and this is mg in magnitude, and this angle is going to be equal to this angle, equal to 30. So it will become, this thing's magnitude will become 2 mg cos 30. So that is root 3 by 2. So it will be mg root 3. That will be the magnitude of this vector. So where will my tension be? It will be equal and opposite to this one. So my tension should now be along this kind of line. So my tension has to balance that. So its magnitude has to be mg root 3. But more importantly, it has to act such that now if I draw vertical and horizontal in this is the vertical line. This is the horizontal line. Okay. So you can see that this angle is 30.
तो 30 डिग्री हो जाएगा ना वर्टिकल के साथ.
So tension will act at 30 degrees. So inside your this thing, your rope will be something like this. Where this is the vertical direction. This is the horizontal direction. So this angle here will be 30. That's the line along which tension is acting. Okay, Arman, is this correct? Is this clear?
Yes.
So this is all about vector algebra actually, and that property of two vectors which are equal in magnitude, their resultant is along angular bisector, and the parallelogram becomes a rhombus. That kind of thing comes in very handy in solving a problem like this. All right. So now I'll come back to some of Kritika's questions. Okay, so we'll solve this one.
34 sir.
In this page, right? Okay, so let me rotate this. Okay, so this is the question. Two coils are placed close to each other. The mutual inductance of the pair of coils depends on what? So mutual inductance is always a geometrical property, but you should understand that it's independent of the current and all that. It only depends on the relative position and orientation of the coils. Always mutual inductance is a property that only depends on shape, size, and overlap. It does not depend on which conductor it is made of, or gold or silver or what. And it does not depend on whether or not current is in fact flowing. It is a geometrical property. For example, you remember for two solenoids, mutual inductance क्या होता था? Mu into N1 into overlap length into overlap area.
sir.
When you keep so that itself shows. Okay. So two things you should remember about mutual inductance, guys. One is that the value is only dependent on geometry. It does not depend on anything else. And the second is that mutual inductance of A with respect to B is always equal to mutual inductance of B with respect to A. For the same pair of conductors, it does not matter which one is the primary and which one is the secondary. The coefficient of mutual inductance will be the same.
Okay, sir.
These are two important things. Anything else on this page? 35 is clear?
सर मतलब अगर हमने अगर ये ज्योमेट्रिकल प्रॉपर्टी है तो अगर हमने क्रॉस सेक्शन एरिया चेंज किया तो फिर चेंज होगा ना?
फिर change हो जाएगा. Like for example, your two rings are the same, okay, but now let's say you had originally kept them coaxially, but now you move one from the axis of the to a slightly on the side, so coefficient of mutual inductance will change. Individually उनके areas नहीं change हो रहे, but overlap area is changing in such a way, so the coefficient of mutual inductance will change.
Okay.
Okay, or if you start rotating one of the rings about some diameter, okay, so again the mutual inductance will change. Okay, is it clear?
Yes, sir.
Okay, let's come to the next one. So this one 36th.
Yes.
Oh.
Sir, how to
So
solve
let's
such
just-
types of question?
Okay, let's just go through the question. So rectangular loop like this you have, okay. Sliding connector of 10 centimeters, uniform magnetic field perpendicular to the plane of the magnetic induction is this much. So basically, see here what is happening. You don't have any EMF source like a cell or a electrolytical cell or a chemical cell or anything like that. But instead, within the circuit, you have a moving conductor which is in a magnetic field. So always remember, a moving conductor in a magnetic field acts like a EMF.
Yes,
So
BVL.
BLV. So draw an equivalent circuit which has the moving conductor replaced with an EMF source. No, so that's how you do it.
सर
So
सर उसमें जो आईबीएल फोर्स रहेगा वो वेलोसिटी के ऑपोजिट डायरेक्शन में एक्ट कर रहे थे, फिर वेलोसिटी को डिक्रीज होना पड़ेगा ना?
No, but I don't think the question is to do with that. And the source is already moving. I mean, some external agent is moving that rod at a constant velocity.
Okay.
So that rod. So this is. You should be getting my whiteboard now. No? So that what is happening? You have this resistance of 2 ohms. On the other side, you have a resistance of something else. That is 3 ohms. Okay. But in between you have this conductor which is moving with a velocity v. And let me assume that the magnetic field, though not given in the diagram, but suppose it is into the plane, then we can even work out polarity. So if this length is L, the EMF induced will be BLV in magnitude, because you can see velocity is perpendicular to the length and the magnetic field is also perpendicular. But what will be the polarity? So V cross V यहाँ कैसा ऊपर के तरफ है. So electrons will be pushed down. So this will act with this kind of polarity. This side will be having negative, this side will be having positive. So equivalently, that rod acts like a cell like this with an EMF of BLV. And that cell is connected with R1 and R2 in parallel. So you can just work out the rest, the currents. So this current I will split into I1 and I2. So I2 and I1. And I1 will be EMF divided by R1 and I2 will be EMF divided by R1. So simple. Okay, in this you don't have to worry about the forces like magnetic force and all, because it's clearly
Okay.
saying that it's being moved with a constant velocity.
Okay, sir.
Okay. All right. So let's come back to. Okay, next I'm coming back to one of Arman's questions. Yeah, there were some good questions in this I wanted to discuss. Right. So hang on a second. Okay, so this one, yes, you can see it on the board now. So the mass is in equilibrium. It is further displaced by x and release. Find its acceleration just after it is released. Okay. So this mass over here, it's initially in equilibrium, and then let's say you're pulling it down by 1 centimeter, which is x given as x. In terms of that x, how much will be the upward acceleration? That's what you have to calculate. So constraint relation ka problem hai. You have to find out that when you pull the block down by x, how much the spring gets extended by. And if the spring gets extended by that much, how much the new tension in the spring is, and you make the FBD. Understood, na, Arman?
Yes, sir.
Okay, so all you have to do is develop the constraint relation properly over here. We had this spring going around like this with a thread, another pulley over here. And that thread is going around that other pulley and it is attached to the ground. There is this pulley and this spring attached to a ceiling. And now you've put some block like this right now. Okay. So initially it's, let's say, in equilibrium. And the spring is having an extension of x naught. You realize that the tension in this thread right now so that tension is equal to kx naught on one side, and so this tension is T naught, and 2 T naught is equal to mg. So from this you have that x naught is mg by 2. Now the next thing is, from here you're pulling this block down by a certain distance x. So when you pull the block down by a certain distance x, if this is coming down by x, this part is also coming down by x, this part is coming down by x. So the change in the new value of x for the spring will become how much? X naught plus 2x. Understood now why?
Yes.
Because this total length is the length of the thread plus the length of the spring. So let's say the total length is the length of the thread plus the length of the spring. So the total thread length from here to here, thread plus spring length from here to here has changed by how much? 2x. So delta of this L total should be equal to delta of the thread, which is 0, plus change in length of the spring. So this has totally changed by how much? 2x. So the spring's length has also changed by how much? By 2x. So that's why the spring is further extended by 2x. Is this clear, guys?
Yes.
This is the key to the problem. There's nothing else in it. This is the important thing to understand here. Kritika, is this clear?
Yes, sir.
Okay, very good. So if this is clear, now you can see the new FPT. So in the new FPT, the tension will change to T. So that T will be equal to K into X, the new value of X. So it is K into X naught plus 2X. So K into X naught, remember, was how much? It was mg by 2. So this is mg by 2 plus 2kx naught. That is the new value of tension. So the new value of tension is that much, means on the block attached to the pulley, you can see there is 2T acting, the block's own weight mg acting, and so it has an upward acceleration of T. So 2T minus mg is equal to mg. And now you just substitute. So mg cancels out actually, as always. And this was 2kx. We have 4kx is equal to m. The linear acceleration is 4k by m into x. This is the amount of acceleration the system has. At the moment when you release it, after pulling it down by x, the moment you release it, this is the acceleration the system will have. Okay, people, hope this question is clear.
Yes.
Oh, good. Now moving on to another problem of constraint relation.
Sir, sir. Sir,
Yeah.
sir, I have one doubt. Sir, can you put that
In which
whiteboard?
question is it? Okay. Yes, madam.
सर इसमें वो mg by 2 plus 2kx naught कैसे आया था सर?
mg equal to कैसे है? From this equation, na? See, this initially this is an equilibrium, na? Before you pulled it down by x, system is in equilibrium, na?
Yes.
In the black colored part of the diagram, the block is in equilibrium. So the tension acting on it is 2T naught. That is balancing its weight.
Okay. Okay, sir.
So T naught is equal to 2 and T naught is nothing but kx. So from that. Whereas when you pull it down by x, the spring extends by 2x. So the tension actually increases by factor of 2kx. But there's double tension acting on this. So the excessive force is becoming 2 into 2, 4kx. So that is why you are getting the acceleration as the excessive force 4kx.
हाँ सर समझा.
Oh, okay. Okay, let's move on to this next question now. So 5.48, we'll do this. So just go through this, I'll explain what you have to use. So the pulleys are massless, P1 and P2. P1 is fixed. E, B, C are masses are given to you. All contacts are smooth. And the string is massless. Theta is 37 or tan inverse 3 by 4. So what you'll tend to see here is that the block's B's mass is 2m, whereas the block C's mass is only m.
Yes.
Okay. But on C, the tension acting is 2T. Whereas on B, the tension acting is only T. So all the more there is a tendency for B to come down and C to go up.
देख रही हूँ ये क्या है? काकू की इसकी तरह.
Ritika, is the question clear?
Yes, sir.
So see what is happening in this system. The tendency will be for B to come down and C to go up. There are two reasons for that, because B ka mass भी 2m है, C ka mass kam hai, it's only m. And secondly, on C the tension acting is 2T upwards, whereas on B the tension upwards is only T. So we can assume that when we release the system, the tendency will not be for C to go down and B to simply lose contact with A and come up. Rather, the tendency will be for B to come down and C to go up. Now we assume that tendency, what will happen to the block E? If B is coming down, the block E has to get pushed towards the left.
Yes.
So you take some horizontal acceleration of block A towards the left as, let's say, A1, and take the downward acceleration of block B as A2, and take the upward acceleration of block C as A3. We have three acceleration
Sir,
variables.
what is being conserved here?
I'll tell you better. So you take the three variables A1, A2, and A3 as the accelerations. Okay, horizontal for block A, vertically downward for block B, and vertically up block C. So we have three variables in terms of acceleration. Then there's some tension in the thread, so that's a fourth variable. And then there's some normal reaction between the two blocks A and B, so that is a fifth variable. So you require 5 equations. So now you have to think how you will generate 5 equations, because FBDs will give you only limited types of equations. You get only 3 equations from FBDs. So where your other 2 equations will come from is from constraints. So there's no conservation principle will apply here. Yes, of course, work energy can be applied because all the surfaces are smooth. So overall mechanical energy will be conserved. But we want to find acceleration. So there's no point in applying work energy here. What we have to apply is Newton's laws. We have to solve the FBDs, but solving follow better.
Sir, इसमें 5 variables कौन-कौन से थे? एक तो acceleration of A and B and C, then other 2 variables.
Tension and normal reaction. The
Okay.
tension in the thread will be an unknown. Reaction between A and B, that is an unknown quantity.
Okay, sir.
So you will have to generate new equations. So the extra equations will come from constraint relations. Now, what constraints are there in the system? That is relevant. Rather than conservation principle, what are the constraints? So there's a constraint between the downward acceleration of B and the upward acceleration of C. Why? Because the thread length is conserved. And there you can use the virtual work or virtual power method also. And the other is a constraint relation between acceleration of E and B, because they are basically remaining in contact. So there is the wedge constraint concept.
Okay, sir.
I follow you? Okay, so what we do here,
Okay.
we have to understand the constraint relationship. Okay. So one is this kind of constraint, that we have a block E like this. And a block B like this. Now, if this block is coming down with A2 and this block is moving horizontally with A1 and this angle is theta, there's a constraint. And that constraint we have to work out, that A1 will be some factor into A2 and this factor will be a function of theta. So work that out. That is one constraint. And the other is, of course, it's very simple. The block B even though the pulley is actually attached in a slightly different manner, but the same thing. There is this. So if this is going down with A2, but this is going up with A3. So for this you can see very easily that A3 will be half of A2. Sorry, yeah, half of A2. This is the other constraint relation. So this is like your second equation. This will be your first equation. And rest to do from free body diagrams. I'm just making a rough version of the whole diagram. The whole thing's diagram is something like this. It has one less pulley than what I've drawn, but just drawing it for more convenience like this. So this result will be the same as for the one in the question. Only there, these two pulleys are combined into one pulley over here. But rest of the things are, and all surfaces are frictionless. Okay. So now in terms of forces, you can see that इस पे कैसा normal reaction act कर रहा है. On the block B, there is equivalent of normal reaction like this, and there is tension. On this there is heat. So if you come to E's free body diagram, this normal contact force like this. So n sine theta will be mass of A into acceleration A1. That's the third equation we get. On the block B, now on B I'll have to show all the forces acting. There is this n, there's some normal reaction from the wall, let's say N1. There's tension from above. There is weight. And it's having an acceleration of A2 downwards. So once again, this angle is theta. So weight of B minus this normal reaction ends vertical component, okay, minus P is mass into acceleration. That's your fourth equation. And finally, on the other side for block C, a very easy equation. So weight minus 2P is mass into acceleration. So you see, I've got 5 equations, but I have to still solve the constraint relation equation, which I've just left out for you to solve. This one, this constraint. So how does
It
this
is
constraint
cot
relation
theta.
equation come? See,
A1 equal to A2 cot
cot.
theta.
Yes, correct. Very good. Okay. So if this moves like this, then that much time this would have moved like this. So if you take the vertically downward displacement of B as y2 and the horizontal displacement of A as x1, okay, so they will have to maintain this relationship that this angle is theta. So as you can see, y2 by x1 is equal to tan theta, or y2 is equal to x1 tan theta. So now double differentiate this and you'll get that A1 is equal to A2 cot theta, or A2 is equal to A1 tan theta. And theta here was given as 37. So A1 is 4 by 3. This actually becomes your first equation. Then this is your second equation between A3 and A2, and then you have these other equations. So these are the equations that you use to solve this problem.
Okay, sir.
सर एक डाउट है.
And Kritika, I hope this is clear for you also. Okay, so
सर
can you manage the values yourself? Yeah.
सर ये ऐसे कंसर्न ऐसे टाइप का जो क्वेश्चन रहता है उसमें हम लोग को क्वेश्चन के अकॉर्डिंग मतलब कुछ भी सॉल्व करने के लिए हम लोग को ये वेरिएबल्स पता चल जाता है कि कितने वेरिएबल्स हैं, तो उसके अकॉर्डिंग हम लोग को एग्जैक्टली उतने ही इक्वेशंस मिलते हैं या फिर उससे ज्यादा भी मिल सकते हैं सर?
नहीं, if you get the required number of equations, then usually जो extra equations होंगे वो consistent होंगे, so they will not give you some different solution.
ओके, मतलब वो कोई एक इक्वेशन कोई मॉडिफाई करके आया होगा.
हाँ, correct. Right.
ओके सर.
Okay. But for example, here that is not happening. You're not getting really any extra equation.
ओके सर.
Now let's move on to the next question in the same worksheet. I mean, same series. Okay. This is also a good question of constraint relation. Okay. So try this one now. Now in this, the constraint is going to be quite a bit more tricky. Okay, so we'll discuss. But you'll realize again that the larger block, the triangular wedge capital M, will have a tendency to move towards the right, while the smaller one, small m, will have a tendency to slide down the inclined plane with respect to the larger one. Ground frame में उसका acceleration अलग होगा, but with respect to the triangular frame, it will have an acceleration which will be at 60 degrees to the horizontal, like that. Okay. So again, you have to develop. So let's say the relative acceleration of small m with respect to capital M is some E prime or something, and the acceleration of the wedge is some E, let's say, and the tension in the thread is T. So you'll have to develop an extra relation which is the constraint over here. Okay, people, is this clear?
Yes.
You have to understand how the constraint works. So I'm just leaving the question on the board for a moment. You just make a diagram of the, just make a note of the diagram and the values if possible. Then I'll put it up on the whiteboard. Okay, so I'm switching to whiteboard now. So I have this triangular frame. Now on this I have this small block kind of thing. There's this pulley which is attached to this. And then the thread is wrapping around the pulley and coming down from this side. And then there's another thread. This pulley is attached to some wall. And now, as far as the angles are concerned, this angle is given to us as degrees. This angle here is also given as 60 degrees. Okay. This is small m, this is capital M. So acceleration of the wedge we have to find out if all the surfaces are smooth. Okay. So as I was saying, here we'll have to assume that the acceleration of the block relative to the wedge is AR, and this one has an acceleration E. Okay, now we have to basically consider the virtual power concept over here for the constraint relation. That will be the easier way of solving the constraint relation. That the net power delivered by tension in the system, that will become zero. So to understand the power delivered by tension in the system, to understand that on this wedge, there is tension here, there is tension here, and there's tension here acting. And that this angle is some theta, whereas this angle is always 60 degrees. This angle initially is 60. Okay, theta is 60 degrees initially. At some point of time, if the wedge is having an instantaneous velocity v, okay, then the power delivered by tension on the wedge on capital M, the power that tension is delivering is plus T into V at this point. Okay. Then again plus T into V cos theta at this point. Okay. It is moving like this. Okay. Minus T into V cos 60 degrees, like this. Okay. Whereas if you look at the particle or the smaller block, what's happening for the smaller block is lying like this on the wedge. So it has an instantaneous velocity, which is the vector sum of the relative velocity with this, like this. And on that, the tension acting is like this. And then you can see because this angle is 60, that's why this angle is 60. That's why here this angle. So the power delivered by tension on the smaller block, that will be P into V cos 60 minus V relative. So are these two expressions clear to both of you? Instantaneous power delivered by tension on the wedge and instantaneous power delivered by tension on the smaller block. Is this clear? Because remember here, the concept here is that the velocity of the smaller block with respect to ground is equal to the velocity of the block with respect to the wedge plus velocity of the wedge. So it is the sum of the relative velocity plus the velocity of the wedge. The velocity of the wedge is only v horizontal. So from this we have taken, so the net velocity of this is the vector sum of this v and this vr. So that's why the power delivered we have to consider like this, right? So now the virtual power theorem is that the net power delivered by tension on the system should be zero. So let's see what that is giving us. So TV plus TV cos theta minus TV cos 60 plus TV cos 60 cancels out. Okay, minus T into V relative. So that tells us that at the instant V into 1 plus cos theta minus V relative is equal to 0. Or V into 1 plus cos theta always balances V relative. Okay, this is what the constraint relation is telling us in terms of velocity. Now we have to convert constraint relation into acceleration. So for that we have to differentiate. And when we are differentiating, we have to keep in mind that theta is a variable. The angle 60, that is not variable, that is constant. But the angle theta over here, that is a variable. Okay. So I'll just have to refresh my whiteboard. But till then, you just try to write the constraint relation here. Just a moment. My whiteboard computer is offline. I just have to relog that in. Just a moment. Right. So should be getting this now. So this is my constraint relation between the velocities. The instantaneous velocity of this wedge on the ground frame, which is v, and the relative velocity of this with respect to the wedge, which is vr. This is my constraint relation. And so I'll convert that to acceleration also, but first let's understand what this is exactly and why I've kept that theta as variable, because you can see theta here is the angle between the thread and this. So as this wedge moves, that angle will change because this is attached here, whereas this is a fixed pulley. No? So when it moves from here to here, you can see this angle would have changed. So this angle is all the time changing. So that's why this theta, in my diagram below, I've taken theta as a variable, whereas this angle is not changing here. So that's why that 60-degree angle over here is constant. But this angle theta is variable. Is this point clear to both of you? This theta is a variable angle, this is a constant angle. Right?
Yes, sir.
Okay. So now see, when we differentiate this, we will get the relation of acceleration. Differentiating, we are getting acceleration into 1 plus cos theta plus velocity into differentiation of 1 plus cos theta, which is minus sine theta d theta by dt, should be equal to differentiation on the other side, which is dr. So this is the actual general constraint relation. It always involves d theta by dt also. But at t equal to 0, when the motion starts from rest, at that point of time, two important things are happening. V and d relative are both 0 because it's starting from rest. So we'll substitute this term as 0. And of course, the instantaneous value of theta is 60 degrees. So at that moment, the constraint relation will become E into 1 plus cos 60 plus 0 into minus sine 60 d theta by dt. So that 0 cancels out this term. Is equal to E. So we have a very simple constraint relation that 3 by 2 E is equal to E. So this is the constraint relation. Now two more equations you have to generate from free body diagram. Okay. And I'm going to put up those equations also, but you try to write them out yourself because they're a little bit complicated. Because the diagram itself is quite interesting, as you can see. So here I've only shown tension. Tension on this wedge, tension on the triangular wedge, and tension on the block. But now include the other forces which are important also and work out the FBD equation also. Okay. And also make sure you understand this constraint relation. So these type of questions are a little bit extra complicated for that reason, because the constraint relation you have to work out very carefully. And if you try to do the constraint relation here by thread length conservation or something, you see it will become extremely lengthy. So it is better that you do it by the virtual power method which I've shown you here. Always, my observation is in any type of problem where there is thread involved, even where there is a rotating pulley instead of a fixed pulley like this one, the easier method for constraint relation is the virtual power method. Okay, so let's look at the free body diagrams also in detail. So this is with respect to inertial frame. Now on the wedge, we have one tension acting like this, one tension acting like this, one tension acting like this, and one normal reaction acting like this. These are all the forces. This angle is 60. The normal reaction angle with the horizontal is 60. Sorry, the vertical is 60. This is 60. And at that moment when the motion started, this theta was also equal to 60. So, and it's having a horizontal axis, no? P. So, P plus P cos theta minus P cos 60 plus N sin 60 is equal to capital N entity. This will just reduce to theta equal to 60 degrees initially. This becomes cancel out. So, P plus root 3 by 2 N is equal to capital N. That's your second equation. The first was the complete equation. Now, when it comes to the wedge, the smaller block, we know the relative acceleration direction is down the inclined plane. So, we'll have to solve this in the non-inertial frame of the wedge. The wedge itself is moving with a horizontal acceleration E lengths. We'll have to include pseudo force. This is a pseudo. Apart from this, there's other normal forces weight. And it has an acceleration down the inclined plane. So pseudo forces cos component plus MV sine component. MA cos 60 plus MV sine 60 minus P. That MA by 2 plus P by 2 MV minus T is equal to M. I might think that we are done because we have three equations, but we have actually introduced one more variable now, which is the normal reaction. So we have A relative tension and normal reaction. So we still require one more equation, and that will come from the fact that in that frame, along the normal direction, the net force is 0. This is my third equation. And my fourth and final equation will come from balancing the forces along the normal direction. So along the normal direction, you can see N plus pseudo forces sine component has to balance Ng's cos component. Okay, so N plus root 3 by 2 small m is equal to you can find. And these were the 4 items. So unfortunately, there is no shortcut in these type of questions, and you cannot quickly write a conservation of mechanical energy equation and differentiate that to get acceleration. I mean, in principle you can, but that will probably take longer because that constraint relation is quite complicated. So it is better to actually work out the constraint relation for the accelerations and then make the FDT equations. Okay, so Arman and Kritika, is it clear? Can you manage with the equations from here?
Yes, sir.
Okay. So just come to one more question. Okay, let's look at this paragraph now. Is we want to apply a force such that the normal reaction between the block and the wedge becomes 0. So what is the condition for the normal reaction to become 0? The pseudo force plus the tension together should balance the weight.
Yes.
Okay, so all you have to do is apply that. Now you can use the trick here. When you make the FBD, your normal reaction of small m becoming 0 in the non-inertial frame, you're balancing 3 forces, no? Pseudo force, tension and weight. So you can use Lami's theorem. So that you will understand that T has to balance MA plus MG. So MA plus MG का net जो line of action है वो T के along होना चाहिए. So you get a sort of A by G equal to tan theta kind of relation. So just start by making the FBD of the smaller block in the wedges frame.
तो
And then
इसमें pseudo force क्यों act करेगा?
because see the smaller block is at rest in whose frame? In the wedges frame, no? In the ground frame, if you draw the FBD, it's moving with the horizontal acceleration A.
अच्छा हाँ, okay.
Right? So you can draw the FBD in the ground frame, but then there are only two forces, tension and weight acting, and their vector sum should become MA horizontal. So either way, it's the same thing.
Okay.
Right? So I think this should work out quite easily. So what all we have to find out: the acceleration E, then the tension in the thread, and the net force on the wedge. Net horizontal force on the wedge. Okay, we'll see that also. Okay, so the frictionless surface ground is also frictionless. Capital M, small m, angle theta, and you are pulling the system with a horizontal force F. Now we want that the normal reaction between small m and capital M should be 0. Now the condition for that. Okay. So this whole system is moving with the horizontal acceleration A, let's say, whereas this is at rest with respect to the wedge. Now the FBD of that block in the frame of the wedge itself is moving horizontally at A like this. So that FBD has no force on it, gate MB and tension. Because normal reaction is 0. And of course, the tension is acting along the thread, which is so tension should be equal to minus of mg plus ma. That's one way you can solve it, or T upon sine 90, because this angle here is 90, should be equal to pseudo force upon sine of 90 plus theta. This whole angle here, this is 90 plus theta, this angle, or that should be equal to this angle is theta. This one is 180 minus theta. So it should be equal to mg upon sine 1 to n. So tension should be equal to ma by cos theta should be equal to mg by sine. So this is, from this you will get all the parts quite easily up to tension. Now we'll also see the net horizontal force on the wedge. That's okay. So once I get this from this, I'm getting A as g cot theta. So this is coming from that theorem that the vector sum of three forces is 0. And the condition is that Lami's theorem, or that cosine rule for a triangle. Sorry, sine rule for a triangle. This angle is alpha, this angle is beta, and this angle is gamma. So using that, A upon sine alpha is equal to B upon sine beta is equal to C upon sine gamma. This particular principle. This is what I'm applying over here. The condition for the vector sum to be 0. So this is clear, right? Now, when we are talking about the net horizontal force on the wedge, very easy. Net horizontal force on the wedge. That is just equal to capital M into E. You don't have to worry about working out tension and F and all that. Because on the wedge now, there is tension acting like this and there is F acting like this. So the net horizontal force is actually F minus T cos theta. But we already know, because normal reaction is not there. And the other forces are vertical, external forces. So we already know that this is equal to M into E. So we don't need to calculate these values. Whereas if you want to find out the value of capital F, then it is better to make a combined FPD. If you want to find out how much force we are applying on the system, the external force, then it is better to make a combined FPD including everything. This whole system is having external forces only F and combined weight and some normal reaction from the ground. So that is giving the system a horizontal acceleration. So the force that the external agent is applying, that is in fact more than ma. It is m plus m into e. But the net horizontal force on the wedge, that is only this force. That is capital M. So that's another thing which can get a little tricky if you're not careful about what you're applying. So that is how it applies.
Okay.
Okay, people. So that's about the solution of this. Okay, Arman. So hope this question is clear, beta.
Yes, sir.
Okay. So I'm just sharing another couple of questions sent by Kritika. So we look at this 45th question now. So bulb is this 45th question on the board. So the bulb's rating is given to you 100 volts, 100 watt. It can be treated as a resistor. Find out the inductance of an inductor that should be connected in series to operate the bulb at the rated power with the help of an AC source of 200 volts and 50 hertz. Okay. So we want to connect. Yeah.
तो सर मैंने इसको ऐसे किया कि पहले मैंने रेजिस्टेंस निकाला,
हाँ.
देन उसके बाद मैंने
So you use the formula that power is V square by R to find the resistance.
yes देन उसके बाद मैंने वो जो न्यू न्यू वोल्टेज है दैट
हाँ
अपॉन सम इम्पीडेंस Z इज इक्वल टू 100.
नहीं बेटा, power always has a power factor also. Remember in EC circuits, the formula for power is what? It is EIRMS ERMS into IRMS into cos phi.
Yes sir.
So you have to use the power factor formula in this. So
Okay.
that is, it will not be EMF squared, voltage squared divided by Z. Okay. We have slightly more interesting formula than that. Okay, so let me explain.
हाँ सर मैंने वही यूज किया था पावर फैक्टर फॉर्मूला दैट VRMS स्क्वायर अपॉन Z.
Then you get the answer. You should easily get the answer.
सर फिर उसमें मतलब मेरा ऑप्शन नहीं मैच कर रहा था.
Okay, let's work this out. So when you connect this as a pure resistor, suppose if you have a VRMS equal to 100, the power is about 100 watts something. The power consumed by the resistor was 100 watts. So that means VRMS square by R is equal to the average power consumption. So the resistance is 100 ohms. Now next up, what you're doing is you're connecting this in series with an inductor. So that the power consumed by the resistor is still going to be 100 watts. But this time your VRMS is 200 volts. And your frequency is 50 hertz. So what we'll have to do this time is the current will become I naught sine omega t plus some phase constant, where I naught is V naught by Z. So your instantaneous power consumed by the resistor is I square R. So it is I naught square R into sine square omega t plus phi. That is the instantaneous power. So the average power consumed by the resistor will become I naught square R into half, because sine square function's average is half. So that is nothing but I RMS square R. Because again that. Okay, so I RMS is nothing but V RMS by Z the whole square into R. So V RMS was 200 volts. R I want to find out in ohms. Oh, sorry, Z I want to find out in ohms. Into 100 ohms. This is your average power. So this should be equal to how much? It should be equal to 100. Okay. So what does that tell you?
So Z has to be 200.
Z has to be equal to 200. That's it. So square root of R square plus XL square has to be equal to 200, and R is already 100. Okay. That means XL has to be how much? 100 root 3. Correct. So omega L has to be 100 root 3 ohms. And omega is 2 pi f or 100 pi radians per second. So this is the solution of the question. Now you just have to see whether the answer is matching properly or not. There might be some correction otherwise in the question. Okay. But don't confuse the average power supplied by the cell with the average power consumed by the resistor. That's a different thing. Okay? The average power from the supply, that is going to be what? I into E ka, I into V ka average. So that is I naught sine omega t plus phi into E naught sine omega t average. So that comes out to be ERMS into IRMS into cos phi. Oh, that here works out to be this only because I think the inductor consumes an average power of 0.
सर वो ऊपर बार साइन किसके लिए?
Average.
अच्छा,
Instantaneous and average. Right? Okay, so this is the correct formula. This is how you should. This is how you should be getting it.
okay.
Alright, beta, is this clear?
Yes, sir. Sir, can you come to 41 question?
41 question. Wait. Okay, the triangular waveform one.
सर वो क्लास में जब पढ़ाया था तो मेरे को समझ में नहीं आया था कैसे निकालते हैं.
Okay, well, I'll take. What do you have to calculate the RMS? This question, no, voltage time graph is given as a triangular form. RMS value of V in time interval 0 to t by 4. Okay. So actually, the RMS value of 0 of V from 0 to t by 4 will be the overall RMS value only. Because it's quarter time period, no? So quarter time period may repeat ho jata hai. So let me explain how that works. So just take a look at the question first, both of you.
सर RMS वैल्यू वेक्टर सॉरी स्केलर क्वांटिटी रहता है क्या?
Yeah. Voltage is also a scalar quantity only. So there is voltage has polarity, but it is scalar.
सर नहीं मतलब अगर वोल्टेज की जगह अगर कोई और अलग वेक्टर क्वांटिटी होता है
So come again, voltage.
सर तो मतलब अगर वोल्टेज के अलावा अगर कोई और वेक्टर क्वांटिटी होता तो उसका अगर आरएमएस होता तो वो स्केलर ही होता ना.
हाँ, you'll have to convert. I mean, see, RMS का मतलब सिर्फ इतना है that it is square root of mean of square.
Yes.
Root of mean of square. You're talking about it applied to a vector quantity also. You're first squaring it and then averaging it and then taking square root. No? So square of a vector typically means magnitude square, like that. So
Okay.
So here your voltage versus time. Suppose this type of a graph now. So this is what is in technical language called a triangular waveform. So this is the general pattern, where you can see that one cycle in terms of time, this is the completion of one cycle. So this is the completion of half a cycle, and this is the completion of quarter cycle. So we have to find VRMS. So that is square root of mean of square, where that is basically square root of mean. कैसे calculate करते हैं? By integration, whatever time interval we are calculating. So this is the method that we use. Okay. So here we want to calculate VRMS from 0 to t by 4, that much time. Just for that much time we want to calculate. And this value of voltage is V0, the peak value. So what you first do is find V as a function from 0 to t by 2, t by 4. So you can see the voltage as a function of time will be like this. We want to calculate this thing. So first let's calculate voltage as a function of time. So it will be V0 into 4 by t from t equal to 0 to t by 4. See, it's a straight line graph. From 0 to t by 4, it's a straight line graph. No? So y equal to mx type of thing. What is the slope? The slope m is delta y by delta x. So it's v0 divided by t by 4. So it's that much. It's passing through the straight line. So this is clear, beta?
Yes, sir.
So like that, if we wanted to next time interval also, we could have calculated. We could have seen that from here to here, it is some kind of a function. V is equal to m into time plus some y intercept, where the slope for the next interval would become exactly minus of 4 v0 by t, and the y intercept we could calculate by looking at this line. Then again it is some same m. So this would become like a minus m, this would be like a plus m plus c. So this would be like minus m, this would be plus m. That m only is this much, okay, plus some different c prime for the next interval and like that. Okay, but here we are only concerned for the 0 to t by 4. We are only concerned with this part of the formula. This into t, so mx, y equal to mx, that kind of function. So v square is equal to that slope into t ka whole square. So that slope was 4 v0 by capital T whole square into t square. So your v is like this. So v square's average value will be integration of v square divided by the time interval. So if I'm calculating from t1 to t2, lengths minus t1. So next we want to find out v square's average from 0 to t by 4. So it becomes integration of v square, which is 4 v0 by t, which you can also just write as m initially, substitute that later, into t square dt, integrated from 0 to t by 4. The whole thing divided by the time interval, which is t by 4. Okay, so this is how we calculate the v square's average value. Then we'll take the square root of that. So this is the mean square. This v square's thing, this is actually the mean square voltage from 0 to t by 4. So that is becoming 4 v0 by capital T का whole square बाहर आ गया. So integration I'm left with t square dt. So that's t cube by 3 from 0 to t by 4. The whole thing was divided by t by 4. Okay. So now you can see that v square's average value is becoming 16 v0 square by t square into 1 by 3 into t cube by 64, 4 to the power 3, the whole thing divided by t by 4. So finally this will come out to be b naught square into 16 into 1 by 3 into 1 by 64 into 4. So 60, so this will be 1 by 3. Correct?
Yes.
So now RMS, VRMS. That will just work out to be square root of mean square. That is square root of V naught by. Okay. Now it's actually true here that this RMS we have calculated from 0 to t by 4 only, but it is also the same for 0 to t by 2 or even 0 to t or any large interval of time, because while the velocity time graph, the voltage time graph is a little bit up down, but when you square it, you'll see it's very symmetrical. You look at the voltage time graph, it's the same between all these time intervals. So I may have labeled something wrong in this graph. Also, this thing here is t, my mistake. No. This time will be 3t by 4. And this time in between here, this is t by 3t by 4. Anyway, so this is V versus T. So you can see that in between this and this, 0 to T by 4, it is not symmetrical with respect to 0 to T or something. But if you see the whole square of this, that's symmetrical. The whole square graph will be like this.
Yes, sir, got it.
So Aman and Kritika, I hope this part is clear to both of you.
Yeah.
So
Yes.
guys, I'll have to wind up another second. But you can send me the remainder of your doubts on WhatsApp, and I will send you some hints, and if required, we can discuss that further. Okay?
Okay, sir. Okay, sir.
So can you share the recording of this, please?
Yes, I will be sharing the recording. I will send it to you. The recording and the white screen, both of the things I'll share.
Okay.
Yes, sir.
Okay. Okay.
Thank you, sir.
Sir, can you send it on WhatsApp?